All right, everybody, we jump into part three here, looking at questions 41 through 60. And 41 starts with proving that this figure, FGHJ, must be a parallelogram based off of one of these statements down here. So we'll scroll down to get the statements in place, though we lose the picture. We are given that F and G add up to 180 and F and J add up to 180, and use that to prove that it actually is a parallelogram. As with every which of type question that's a multiple choice, we're just going to check off the answers and see which one actually makes sense. So if we start with A, according to angle addition, F and J have to be the same and G and H have to be the same, therefore it must be a parallelogram. You're given that they add up to 180, but there is nothing in the given that says they have to be the same number. And clearly we can do more than just 90 and 90 to add up to 180. You could have an angle that's 120 and an angle that's 60 and several others. So A doesn't work out for us. In B, by the converse of same side interior, we get two sets of parallel lines, and therefore by definition it must be a parallelogram. That's 100% true. If the same side interior angles add up to 180, which they do in the given, you must have parallel lines, and as soon as you have parallel lines, you've defined your parallelogram. It has to be B. For 42, we're given another parallelogram proof, but this time the reverse task. Of everything that's already been listed and put together, you're asked to figure out which one of these things doesn't need to be in the list here. So let's just read through them all. We're given that we have parallelogram, which means the opposite sides are congruent for line 2. Angle A and angle C would be congruent because opposite angles are as well. BD reflexive to itself, that's a true fact. And then the triangles that are inside this parallelogram are congruent by side, side, side. So let's go through and read off. We guarantee ourselves we need the given. We have to have that line. And we have to have what we're trying to prove. So the triangles were congruent by side, side, side. Those two steps have to be there. Of the other three, one of them doesn't need to be. And the clue is in how they proved the triangles congruent. The triangles were proven congruent by side, side, side. So you have one side congruency, a second side congruency, and a third side congruency. We didn't need the angle one, even though it was a true fact, it wasn't needed. Step 3 is the one we could throw out of that one. For 43, we're given another parallelogram here. We're told S to V is x plus 3, V to U is 2x minus 1, and T to U is 4x minus 3. You're asked to figure out the length of SV. Well, let's use the property of a parallelogram. The sides that are across from each other have to be the same length. So x plus 3 and 4x minus 3 have to be the same length. If we subtract the x over, we end up with 3x. If we add the 3 over, we end up with it equaling 6. Divide out the 3, we've discovered that x is 2, but the question was to figure out the length of SV, so I need to go plug it back in. This x plus 3 becomes 2 plus 3, so the length of S to V must be 5 units long. For 44, we're asked which value of x would turn this into a parallelogram. So same logic, just we're going to change the phrasing. Instead of saying it is a parallelogram, so we know the opposite sides are congruent, we're going to change it around to like an if statement. If these two sides were congruent, so 12x minus 5 equal to 10x plus 5, then it would be a parallelogram. So what would make this true? Let's go solve the algebra. If we subtract the 10x off, that's 2x. If we add the 5 over, it's equal to 10. Divide out the 2 and get 5. We just change the phrasing of the sentence. Instead of saying this is a parallelogram, so we know x is 5, we reverse the sentence. If x was 5, then this would become a parallelogram. It's the same work, just a little play on the sentence structure. All right, with 45, we start jumping into some of the construction problems. So you're asked, given this picture here, what's the very first step in building congruent angles? And if you go back and look over the construction section, the very first thing you have to do to build a congruent angle is we have to start figuring out how wide the angles are. So we have to draw this first arc on each angle so that we can do that. If you read through your list here, the only one that discusses doing that is from both A and D, draw an arc that creates that. All right, for 46, Melanie wants to construct the perpendicular bisector. So which diagram shows the first step? From either the constructions lesson or from back in chapter 5, any point that's on the perpendicular bisector ends up being equidistant from the ends of the endpoints of your segment. So if you start looking at these 4 pictures, there is only one picture that shows 2 circles overlapping and equal sized, equal distance, and that has to be picture B here. A will fail because they don't overlap. D will fail because they're differently sized. C will fail because there's only one. That's the idea. And see, for 47, you're told the perpendicular bisector of DC is AB, and the perpendicular bisector of AB is DC. So you are told you have 2 perpendicular bisectors, and then you're asked which of these statements has to actually be true. Easiest way to understand it, because of how it's phrased, is to actually draw it. So here we'll take A and B, and here we'll take C and D. We put endpoints on it since it was a segment. So C and D. And you're told they're perpendicular bisectors of each other. So A to B has to be split in half, and C to D has to be split in half. And you're told that their intersection was point E in the middle. Now it's a matter of just check off until we find the right one. So C to E is equal to C to D. That's not true. C to D is the whole thing. A to E matches D to E. That's not true. That's 2 different line segments. They're bisectors of each other, but nothing says they have to be the same length. The short one could be 2 and 2, and the long one vertically could be 8 and 8, for example. AB matches CD. Same argument, just the entire segment instead of just the halves. EB matching CD, same problem, 2 different lines. The only one we can guarantee is true. D to E, the bottom portion, matches C to E, the top portion. That's what bisect means. It was cut in half. Answer has to be E. Let's see, for 48, Adam is constructing the bisector for angle R and has made a mistake in it in the picture that you see here. So the question becomes, which mistake has been made? When you go to build the bisector of an angle, one of the first things you have to do is you have to have the size of the angle. So starting at the vertex, you have to create an arc so that you can do a next one off of each endpoint. But you start reading through the answers, C describes that. Started at the wrong place, should have started at R, the way we just drew in the picture up there. The 49. You've been asked to place a warehouse so that it's an equal distance from the roads in the map. So it's got to be somewhere in here. And you're asked what constructions would you need, and then what would that point, that blue dot for the warehouse, be called? Well, if you want to be equal distances from the roads, so we're going to go from there to there, there to there, and there to there. If you want to be equal distances from all the roads, those 3 lines have to be radii of a circle drawn inside, which is the biggest clue you need in the whole problem. These must be angle bisectors because the only way you create a center on the inside of the circle is the answer to point B. It must be the incenter for the triangle. So honestly, it'd probably be easier to solve part B first. That dot for the warehouse has to be the incenter, which now goes back to part A. It must have been created from the angle bisectors. For 50 here, you're just asked to figure out what is this point A called. So let's look at how it was built. I see a congruency mark and a congruency mark with a right angle. That is bisecting the side at a right angle, has to be a perpendicular bisector. I'm not going to draw the other 3, but if you check the other sides, you'll easily see split in half, right angle, and therefore they all meet up at the circumcenter. So that one's a quick one. As soon as you notice it's been perpendicular and bisector, instant answer. For 51, which construction is being shown by the method in the picture? We go back to a previous problem, the one where the girl wanted to create the perpendicular bisector. You're creating two overlapping circles or arcs, so you're creating a perpendicular bisector. If you read through them, the only one that discusses bisector is B. So they're interested in just bisecting it. The perpendicular part would happen to come along for free. Let's see, for 52, what construction is being created here? Again, we go back to another previous question. You've created an arc or a circle, and then you're measuring off of each one. That is cutting it in half, because that was the one a few questions ago that was, what was the error that was made? This is the picture that's showing you being it drawn correctly. All right, for 53, we jump back into some algebra based off of properties. So we'll leave constructions behind for a little bit. You're told this figure is a parallelogram, and then based off of that, figure out the measurement of angle ACD. So this one down here. Let's go through and start building some logic in it here. You know you have a triangle, so we can add all three of these up here really quick and easy. So if we add up the x's, 5, 6, and 7 will be a total of 18x. 16 and 5 is 21, minus 3 will be an 18, and should equal 180 from being the triangle on top. If we subtract the 18 off, 18x will now equal 162. If we divide the 18 out, comes out to be 9. But you're asked to figure out this angle, and now's where parallelogram is going to kick in. Since you have a parallelogram, we have a pair of alternate interior angles. So I'm going to plug that x back into the one at the top, 5x plus 16, to solve my problem. 5 times 9 is 45. If we add 16 more, that comes out to be 61 for the correct answer of C. For 54, we're told that these two triangles are congruent and asked to figure out the measurement of angle N. So let's use the congruency sentence. J, being the first letter, has to match up to O. So I can move this 60 over to here for angle O, at which point now I can go solve this triangle problem. 180 minus the 60 and minus the 56 leaves me with 64 degrees for the measurement of angle N. All right, 55. You've got, scroll too far. You have an equilateral triangle and an isosceles triangle sharing a common side here. So we can start building a problem. You're asked to figure out the measurement of angle ABC up here. So let's do the left triangle first. Thanks to it being isosceles, I can add another 67 down in this corner, at which point that's a grand total of 134 degrees, and that leaves me 46 for this top portion up here. So I know I have 46, but that's only this part that I'm shading in right here at the bottom portion of B. I still need the rest of it to make the full angle ABC, and that's where equilateral kicks in. An equilateral triangle, every angle 60 degrees. So the 46 that we found from the isosceles plus the 60 that would have to be in the equilateral one makes the entire angle 106 degrees. See, for 56, you're asked to write an equation to find the value of y and then solve for the measurement of angle k. Again, let's use the isosceles triangle theorem. The angles across from the congruent sides have to be the same. So 5y minus 19 has to be the same as 56. If we add the 19 over, 5y will be equal to 75. At which point, if we divide the 5 into that, we'll get that y is equal to 15. You're asked to solve for the angle k. The value of y doesn't do anything for solving for k. You already knew for a fact, if you plug the 15 back in, I promise you it's going to come out that angle L is another 56-degree angle. That's something you already knew courtesy of it being an isosceles triangle. Angle K is simply a plain old triangle problem. 180 minus the 256's that we already know leaves me with 68 degrees for angle K. See, for 57 here, we have this picture showing a parallelogram, and you're asked which of the following would actually prove, sorry, showing a quadrilateral, which would prove it would actually is a parallelogram, which is basically, do you know your definition of parallelogram? So let's go check everything. The slope of AD matching the slope of BC, that would make the left and the right parallel. The length of AD and the length of BC, that would make them congruent, but that's only one set of sides. A parallelogram needs both. So that doesn't help us. The slope of AD matching the slope of BC, so the left and the right would be parallel. The length of AB and the length of AD, so that, sorry, that's a typo. That's the length of AB and the length of CD. That is a typo on that one, because the correct answer is B. For 58, considering a quadrilateral, and a task is to prove that it's a square, so the question becomes, who's got the correct method? So one person says we need to show that the slope of AB and the slope of CD are the same, and then BC and AD are the same. Second person claims we need to show that AC and BD are the same length, and the slope of AC and the slope of BD multiply up to be -1. Easiest way to check this is to actually go draw it. So here we're hoping to prove that this is a square. So here's A, B, C, D. Let's use Jillian's from part A. If we show that AB and CD have the same slope, that's parallel. BC and AD have the same slope, that's another parallel, but that's not proof of a square, that's proof of a parallelogram. So Jillian's doesn't work, which we come down here. Jillian's only, no, and if Jillian's doesn't work, we can't possibly argue both. So we have a 50-50 shot. Either Tammy's is correct for B, or Tammy's doesn't work and we go with D, nothing does. So for Tammy's, let's draw the same picture again. A, B, C, and D. We should show that AC and BD are the same length. That's the diagonal going across here and the diagonal going across here. If those were the same length, that's proof that we have rectangle. And then the slope of AC and the slope of BD multiply up to -1. That would be opposite reciprocal for perpendicular. That proves we have rhombus. If it's both rectangle and rhombus, then it's a square. So Tammy's method is perfectly valid. That would prove perpendicular and congruency, all we would need. See, for 59, we jump into a little bit of distance calculation. We're asked to classify this triangle based off its lengths. So we just got to find the distances of each one. We'll just do them in order around the picture. From A to B, we'll take the square root of, see, from 8 to 2 is 6 squared. And from 6 to -5 is 11 squared. That'll be the square root of 36 plus 121, comes out to be the square root of 157. Remember, for classifying problems, I'm not concerned about the actual value of the square root of 157. I just need the comparison. All right, from B to C, 2 to -5 would be -7, and that's going to get squared. And then from -5 to 1 would be 6, and that's going to get squared. That's going to be the square root of 49 plus 36, which will be 85. And then last but not least, from C back to A. So we'll take the square root of -5 to 8 is 13 squared. 1 to 6 is 5 squared. So that is the square root of 169 plus 25, which is 194. All three lengths are different. This must be a scalene triangle. Which then, last but not least for this chunk, in 60, Cameron's going to pass the ball and is asked to figure out the shorter pass. So who should he pass it to, Arthur or Jamie? That's basically, let's just do two distance calculations and figure it out. So Cameron sits at, let's see, 55, comma 45. Let's see, let's do Arthur's first. So Arthur is at 15, comma 30. If we do the distance from Cameron to Arthur, I don't want to try and cram it into the space in the picture though. So the square root of, from 15 to 55 will be 40 squared. From 30 to 45 will be 15 squared. So that'll become the square root of 40 squared plus 15 squared. The square root of 1,825. And see, Jamie sits here at 40, comma 15. So from 40 to 55, it'll be 15 squared. And from 15 to 45, it'll be 30 squared. Don't even really need to calculate this. You already know the distance to Jamie's shorter. The 15's matched and 30 is smaller than 40. So, but just to be thorough, 15 squared plus 30 squared is 1,125. The shorter pass is the one to Jamie. Excuse me. At which point that is everything for this portion of the review. If you've got any questions, make sure you ask your teacher, and we'll see everybody when we jump into the next chunk.